Hello, this is Professor Kuehn, and welcome back to my Introduction to Astronomy course at Wisconsin Lutheran College. We've been doing a close reading of Galileo's famous work, The Starry Messenger, in which he describes his discovery of the moons of Jupiter, his exploration of the stars that comprise the Milky Way galaxy, and the physical geography of the moon, among other things. In my last lecture, we read through his dedication to Cosimo Medici. In this lecture, what I want to do is begin right into the text. So this is on page 230 of A Student's Guide to the Great Physics Texts, Volume 1. This section is titled, and this is the beginning, Astronomical Message, containing and explaining observations lately made with the aid of a new spyglass regarding the moon's surface, the Milky Way, nebulous stars, an innumerable multitude of fixed stars, and also regarding 4 planets never before seen, which have been named Medicean stars. So here, basically, you'll probably notice when you read older texts, in the title, they are very descriptive. So he's talking about how he's using a new spyglass, that is a new telescope, and that he looks at the moon's surface. He's going to be talking about the mountains and valleys he sees on the moon, the Milky Way galaxy. So if you've ever been outside at night in a very clear region, so for example, last summer I was in Buena Vista, Colorado, and I was looking up at the sky, and one can see a faint white sheen over a kind of a strip through the sky. That was called the Milky Way, or the Via Lactea, because it was thought of as kind of a splash of white across the sky. Well, he's going to mention that the Milky Way is actually comprised of many distinct stars that are visible if you look with a spyglass or a telescope. He's also going to talk about the 4 planets, now known as the moons of Jupiter, that were never before seen, and he calls the Medicean stars. So we're going to keep reading this together, and I'll make comments here and there. I hope this is beneficial for you. In the present small treatise, I set forth some matters of great interest for all observers of natural phenomena to look at and consider. They are of great interest, I think, first, because of their intrinsic excellence. Secondly, because of the instrument by the aid of which they have been presented to our senses. So what I'm saying, what I'm saying is not only of interest because they're just intrinsically interesting things that I'm talking about, but also because there's a technological item of interest here, and that is the new device that I'm using. I'm using this telescope, and he's going to mention that the telescope is not something that he invented, but he is using it in a way that was not used before. He says, the number of the fixed stars which observers have been able to see without artificial powers of sight up to this day can be counted. It's about 2,000 or so on a very clear night. It is therefore decidedly a great feat to add to their number and to set distinctly before our eyes the other stars in myriads, which have never been seen before and which surpass the old, previously known stars in number more than 10 times. So in other words, if you use a telescope, you can not only see the roughly 2,000 or so stars that the naked eye can see, but you can see 10 times that many, and that's what he's going to be talking about. Again, it is the most beautiful and delightful sight to behold the body of the moon, which is distant from us by nearly 60 radii of the Earth. So if you think about the radius of the Earth, 60 times that is how far away the moon is. As near as if it were a distance of only 2 of the same measures. So it seems like it's only 2 Earth radii away. So, the diameter of this same moon appears about 30 times larger, its surface about 900 times, and its solid mass nearly 27,000 times larger than when it is viewed only with the naked eye. What's he talking about here? Well, if you look over here at my sketchbook, what we can see is that if you're looking at the moon at night, it's got some size. But when you look at it through a telescope, the diameter of it is about 30 times what it would have been. So the diameter, when viewed through the telescope, is 30 times larger than with the naked eye, or the unaided eye, when you look through a telescope. So that's 30 times larger, that diameter d. Now, remember that the diameter is equal to 2 times the radius, right? So if you think about this being the radius of the moon, the diameter is twice as big as that. Now, what is he talking about when he says the surface is 900 times as big? Well, here you have to use a little bit of geometry. You have to remember, and this might be delving into the past, your geometry courses for some of you, but the surface area of a sphere is given by the surface area equals 4 times pi times the radius squared. You may or may not remember that. So in other words, if the radius, if the diameter in the telescope, I'll call that d prime, the diameter when viewed through a telescope, is 30 times the diameter when you did not look through a telescope, then you can see that the radius when viewed through the telescope is going to be 30 times the radius that it had been without the telescope, and the surface area is going to be, well, 30 squared is going to be 900 times the surface area that it did have before you were looking through a telescope. Why is that? Because if you put a factor of 30 in, radius 30 times as big, 30 squared is 900. Okay? And what about when he says the solid mass is nearly 27,000 times as big? Well, here you have to remember that the volume of a sphere is volume equals 4/3 pi times the radius cubed. Again, some of you may remember that from your geometry classes, some of you may not, but this is a reminder. So in other words, if, as before, the diameter is 30 times the regular diameter and the radius, whoops, let me go back here, something messed up. If the radius when through the telescope is 30 times the radius without the telescope, then if you put 30 in for the 30 times bigger radius, 30 cubed is going to be 27,000 times. So the volume is going to be 30 cubed times the original volume, which is 27,000 times the original volume. So that's what he's talking about here. Okay, so he says, and consequently anyone may know with the certainty that is due to the use of our senses that the moon certainly does not possess a smooth and polished surface, but one rough and uneven, and just like the face of the earth itself, it is everywhere full of vast protuberances, kind of parts of it stick out, deep chasms and sinuosities, kind of like grooves in it. Now, why is Galileo focusing on this? He'll be talking about this more later on in the chapter. But the important thing is that if you remember back to the work of Aristotle, which we read earlier in the semester, Aristotle believed that the heavenly bodies were made of a fifth element, not earth, air, fire, or water, but rather a fifth element, this ether. They were kind of heavenly objects that were very distinct from earthly objects. That idea had carried over into the Middle Ages. What Galileo is doing here is he's saying if you look very carefully at the moon, you can see it very well, and it is very apparent that there are rocks and mountains and valleys and chasms just like the Earth. In other words, the moon is more alike the Earth than anyone had heretofore thought. And so that is going to be really an attack on the Aristotelian view that the heavens are very distinct from the Earth. He's saying the heavens, the moon in particular, is very much like the Earth. He says, then to have got rid of disputes about the galaxy or Milky Way, and to have made its essence clear to the senses as well as to the intellect, seems by no means a matter that ought to be considered of slight importance. In other words, when we look at the Milky Way, he's going to describe that it's made of a bunch of stars, and that's going to be very important. In addition to this, to point out, as with one's finger, the substance of those stars, which every one of the astronomers up to this time has called nebulous, and to demonstrate that it is very different from what has hitherto been believed will be pleasant and very beautiful. So if you look up at the sky, there appear to be certain very tiny regions of the sky that look like little clouds, like puffs and they're called nebulas or nebulosities. And these were seen to be kind of clouds of gas up in the heavens. And what he's going to point out is some of these actually are clusters of stars. And that's going to be very important in cosmology. He says, but that which will excite the greatest astonishment by far, and which indeed especially moved me to call it to the attention of all astronomers and philosophers, is this, I have discovered 4 wandering stars, neither known nor observed by any one of the astronomers before my time. They have their orbits around a certain important star of those previously known and are sometimes in front of it, sometimes behind it, though they never depart from it beyond certain limits, like Venus and Mercury around the Sun. So what he's saying here is, if you look at the wandering star that we refer to as Jupiter, we today call it a planet, they called it a wandering star. If you look at that very carefully through your telescope, you can see that there are 4 other tiny wandering stars that orbit Jupiter and that always stay near it, kind of like Venus and Mercury always stay near the Sun. And he's saying this is an astounding thing. There's a little solar system, so to speak, around Jupiter. He says, all these facts were discovered and observed a short time ago with the help of a spyglass devised by me, through God's grace first enlightening my mind. So he built a telescope and God helped him do it. Perchance other discoveries still more excellent will be made from time to time by me and by other observers with the assistance of a similar instrument. So I will first briefly record its shape and preparation, as well as the occasion of its first being devised, and then I will give an account of the observations made by me. So here's his outline. He's saying, I did all these interesting discoveries. He's kind of ticking them off here. He did them with a telescope. What he's going to do next, he's going to describe how the telescope was built, and then he's going to go into detail about what he saw with them.